Hello and thank you for joining us at Datacloud Europe 2015 in Monaco. My name's Stephen Pritchard, and joining us now from Intel is Jeff Klaus, who is the General Manager for Data Center Solutions at the company. Jeff, welcome.
Thank you.
And welcome to Monaco.
Thank you.
You're looking at, your area of responsibility is the data that can be collected by the devices in the data center and used to make their operations more efficient. How important do you think that's going to be, in particular for CIOs in the next few years?
Well, when you look at the cloud business, it's a big capital asset. It's very expensive to operate. And for an individual that's going to get a power bill, for them to understand what's driving that power infusion, it's the largest operating cost that they'll experience. So this set of capabilities that we're developing, it's a set of APIs that get telemetry from the IT devices, not only rack and blade servers, but also storage devices, which have become a significant part of the growth in the data center, in addition to networking devices. So we're getting all this telemetry, reporting power information and thermal data, and it allows them to orchestrate that data in different methods to understand where the power utilization is coming from, where do they have opportunities to add compute capacity or virtual machines. It can help them increase the temperature in their data center to save money on air conditioning. There are a number of use cases that we packaged with this information in order to allow an operator or a cloud environment to get more insight into that large expense that they have.
And these sensors are now increasingly built into the servers companies will be buying, and they're right down on the microchip in the motherboard, is that right?
They're on the board, they're architected as a part of the chipset, and they started around 2007. That was our Westmere generation of chipset. Since then, it's usually a cadence about every 2.5 years we have a new chipset generation, and more sensors, more and more telemetry get added to the server products. So right now we're just coming off the Grantley generation that launched in September of 2014. So not only do we have inlet temperature sensors, we have an outlet temperature sensor. We can do power monitoring, we can also do power capping in those environments as well. And it's not just limited to Intel architecture. If you had purchased a non-Intel architecture product, we can still gather that data as well so that you can orchestrate and package it together in a way that can be conducive to reporting and efficiency.
So how do you pass that information on to the data center operators and the CIOs so they can adjust their settings and make them more efficient?
The industry protocol we use is IPMI. And IPMI allows us to collect that information in an out-of-band fashion, which means that we don't rely on the OS. It also means that it's a low network bandwidth protocol, so we have negligible impact to the network. And what we're doing is we're taking that information, and we have a discovery engine. You can choose a range of IP addresses. It'll start collecting that data, and then you can start packaging it by IP address and match it up to your physical environment. The uniqueness here is that most of the OEMs customize their IPMI protocol. Dell has iDRAC, HP has ILO, IBM has IMM. They all have their unique protocol. So rather than us providing that information and having the customization ability, we've taken the complexity out of the market and we've just streamlined the data collection, and that's why we're licensing this solution, making it available to a majority of the DCIM players in the marketplace, in addition to OEMs, and we have some customers that license directly from us as well.
So you can either go to your server manufacturer and use their tool, or you can go to write a custom tool if you're big enough, or use a specialist tool to extract that information. What would a CIO then do with that? Because there's always a danger in this industry of information overload. We've all got too many signals and messages coming into our inboxes, too much information on our dashboards. How do you help people understand which of those metrics are actually useful ones?
Yeah, when we started this project, the eyes on a data center operator would glow when they saw the information coming in. Wow, I've never received this before. This is new data that I never had the ability to touch. But then we realized, he said, well, hey, what do I do with it? Can you help me to package this and put it into a report or into a use case that is meaningful to my management? So we've packaged our top 10 use cases. And what we do is put those and package the data in a way that identifies some broader opportunity for efficiency. It could be identifying underutilized servers. You could identify servers that are overcooled or undercooled. So we've enabled the ability for either through a provider or through ourselves to simply press a button to report that use case and then identify where your opportunities are. So that reporting then can go to the operator or the CIO or someone who can identify reprovisioning opportunities. You can either shut those servers off, or you might identify cooling problems or ducting problems within the environment.
What sort of results are people seeing in the industry? Because you've been doing this for a few years now, you've got some good data back from the data center operators and from the OEMs. What type of cost savings are possible?
Yeah, we have a number of use cases with many partners around the world, and we take back that data and normalize it to an average of a 3 megawatt data center, which has on average about 300 racks. The overcooling and undercooling use case, on average for that size data center, saves anywhere from $200,000 to $250,000 or an annual savings. And then we also have the underutilization. That has been a one-time $120,000 to $150,000. So we've normalized those use case data back to what we think is an average size data center, but obviously mileage may vary based on your size. But it's a meaningful number for someone who might not have the insight into this large, capital asset.
And how does that fit into the agenda of making the data center more agile and so more responsive to the business's requirements?
It gives you the ability to make decisions based on more information. If you have more data to make a decision on, or to determine where you put those next servers that are coming in the door, where do I put the new VMs that I just had a request from a different department? Now I see a map with more detailed information. I know that I have more power capacity in this side of my environment. I know that the thermal infrastructure there is much more conducive. If it's red, I'm not going to put more VMs or more devices in that side of the data center. So it gives you the ability to have more information to make decisions and hopefully save money at the same time. So we have customers that are operating colos, and they're offering this as a service. So hey, Mr. Customer, you're bringing your equipment into my environment. Do you want to have the insight into your IT equipment that this tool can offer you? So they're offering it as a SaaS service for customers coming in. And also for customers that are going to a colo, they might be interested to know how much power am I really using? Am I in the price band that they say that I'm in? You can use this information to remotely gather that data to determine, based on this quarter or versus next quarter, how much power am I actually using? I can still operate in some efficient manner from remotely, gathering that data, where the colo is still housing the information, and now I have insight into my devices from a remote environment.
So potentially then the operator or the service provider could pass those savings back to their end customers in forms of lower subscriptions, lower charges.
Or the customer who identifies that they could go down into a lower price bracket, that they might be being charged or should be charged less for power. They could also identify that information much more quickly.
Well, sounds like a fascinating technology. Jeff Klaus from Intel, thank you very much.
You're welcome, thank you.